Thank you. Thank you very much. I think I should start by, I probably owe you an explanation about titles and things. Part of it just came. I have actually, since I had a lovely day today, and I met a couple people who say, Entropy and O-rings. Now you know why. It is part of the book's title. I should explain the source of the book's title. Being an engineer, I had some glorious title, such as What Engineering Is. And one time, while my back was turned, my wife Marion was talking to my editor. They're both historians, and they both concluded that it was a lousy title, so they made up this one. And the publisher sent it through their board, and before I knew it, I got some copy of my book cover. And of course, as you might expect, I then had to go back and rewrite the book, so I included something about flying buttresses, entropy, and O-rings. Perhaps a comment is also in order about the program, which says creativity and technology. I'm not going to really talk directly about creativity. The things I'm going to say, I hope, will convey to you that we're going to need a little more creativity in the future as far as technology is concerned. Let me make one comment about creativity that I think is pertinent. One of the mystifications to me about creativity is that I keep running into people who look at me and say, I'm simply not creative. And the reason that mystifies me is that you don't get that option. You know, if I thought there was some place to go live and be simply not creative, I might move there. But the problem with life is it keeps presenting you with unprecedented options, and therefore you are creative. Technology as a human activity is a terribly creative thing. Companies that are engaged in technology are very creative. And so we are at a high level of creativity, but as I said before, I'm going to mention some things that say that we're going to have to increase it. Now, why did I write this book? The Flying Buttresses book is really a book that attempts to describe engineering and technology to people who are not in the field. And I wrote it because it's kind of a crusade of mine. And among other things, I teach a course in technology and for students who are not technology majors. And it's a challenge. And I've just finished with it again because Stanford is on the quarter system and this is called Dead Week, which is why I'm here. And once again, I have been partly humbled and partly worried by the performance of my class. Students, as you may or may not know, have lots of slang terms, but two of them are techie and fuzzy. Have you heard those? Students use those to sort of talk about each other. Who do you think the techies are? Yeah, they're the scientists, the pre-professionals, the engineers, the pre-meds. Who are the fuzzies? Humanists, softer social science, and so on. And now these terms have always been around, and in fact these may be the old C.P. Snow 2 cultures. And one constant in history has been that techies and fuzzies hardly ever date but almost always marry. I think you know that. But I'm going to show you a few overheads here. This is a separation test. This separates techies and fuzzies. Those are Maxwell's equations. They're very powerful and they're beautiful. But fuzzies would just as soon not. Any of you just as soon not? You just as soon I didn't spend my lecture on these? Okay. That's one side of the house. The other house, little passage from Homer. Any of you just as soon not do Homer? That's a little socially more difficult to admit, but it's out there. Well, there's a problem if you divide yourself into either techie-dom or fuzzy-dom too early. First of all, let me say that with our students, it's not a valid separation. But there are advantages of techie stuff. It's pretty. I mean, scientists, mathematicians, and engineers really get tremendous aesthetic pleasure from it. It's intellectually exciting. Our society values it, and those who are willing to deal with it. It is vocationally useful, and it is impossible to avoid. You buy that? Because interestingly enough, there are also advantages of fuzzy stuff. Same thing. So therefore, if we really are completely biased towards one or the others, we lose something in life. And as I said, the bias that does exist among the Stanford students is not based on at least their SAT scores or their grades. It's based on other things. And I think they tend to be things like this. They don't have to do with mathematical ability or aptitude or what have. They're due to things in their past and influences from other people that cause them to join a tribe. Because people really gain great comfort from being an intellectual specialty or a tribe. For one thing, it simplifies life. If you're a techie, you don't have to spell, and that's easy. On the other hand, you have friends, because, you know, if you look at a university faculty, it's really interesting, because the different departments not only are quite isolated in their specialty, but they have picked up the wherewithal of looking down at other departments. So if you, for instance, go to an academic faculty meeting, each department has a sort of a pleasing contempt for others. And so there's a kind of a feeling good about this. But even though, as I said before, there's no factual basis for it, it's there. And the thing that worries me about this course is that really we have in our prize student body, which is the best we can find with the highest grade ever, a tremendous amount of ignorance about technology, a really stunning amount of ignorance about technology. Now, I say that, of course, with a bias because I'm an engineer, but I'm going to come back to that. What I want to do now is talk a little bit about technology and where it's going and why this ignorance can get us into some problems and what I think we should set about doing. Now, it's easier to talk about where technology is going if we talk about where it is. And it's easier to talk about where it is if we talk about where it's come from. So let me show you a few slides and kind of give you a very brief few jumps chronologically through technology. And the message I want you to get a hold of is that modern technology is really very new to us. The human race, or maybe I should say condition, is somewhere between 2.5 million years old, depending on who you talk to and what you consider to be human. Apparently, from the records, for at least half of that, we haven't even had any fire. So for half of our pastime, the first million years, we apparently just kind of kicked around in the dark and got cold. And we hunted and we gathered and we picked our fruits and we ate our squirrels. But I think you can say that we slowly evolved over that million years. We had tools, but they tended to be rocks. And so therefore, there was technology, but it was very low order, and technology went like this and we went like that. In fact, it was for more than a million years. The first thing that people hooked their hands on was the somewhat confusing Neolithic Revolution that happened maybe 10, 15,000 years ago, and things like this started showing up, bows and arrows. Now, this is a little higher form of technology, but what really happened in the Neolithic Revolution is that people stopped roaming around. They sat still, and they started farming and domesticating animals, and since they had villages, they became more sophisticated architecture. They needed storage devices, so they came up with pottery, and all of a sudden we had wheels and boats and all these kind of things, and technology took a jump upward. And it continued to jump upward. This was about 3,000 years ago from Egypt, the plow. And it looks somewhat similar to modern plows. This was at about the same time from Mesopotamia. It was found in a funeral, a tomb. But clearly there it's a somewhat mechanized, you probably can't see it, but it's a stamping thing to whomp up corn to make meal out of. And the person is sitting there kind of making it go back and forth, so it's almost a machine. But the interesting thing now is we're talking about a few thousand years ago out of a total span of 2.5 million. So technology, after being very flat for a long time, rose up some. But the interesting thing about technology at this stage, it was based on craft. There was some aesthetics involved, but it's very accessible. I mean, you don't have to be an engineer to look at that thing and see what's happening. It's a hammer that somebody's pumping up and down. And it was defined by simplifying the functions of life. In other words, it was subservient to the culture. Now, how about ignorance? Since I'm in a university, I get great joy from blaming classical Greece. And probably you know enough about classical Greece to realize that it kind of is considered to be a pinnacle as far as Western intellectual activity. However, an interesting thing happened in classical Greece. Citizens did not spend much time involved in trade or technology, because that was thought to be a somewhat lower form of life. Slaves did it. So, for instance, even the people like Aristotle, who would design very clever machines for the time, would kind of deny it. In other words, they would design them, but they would make it plain to everybody that this was an intellectual game. So in classical Greece, technology was not linked directly to the economy. These are a couple devices designed by a man named Hero, who was before classical Greece, but one of them is sometimes called the first steam turbine. It's a kind of a lawn sprinkler on a tea kettle, and when you fire up the tea kettle, the steam comes out and it spins. But it was done as a decoration. Now, he also made things like mechanized eagles and things like that. And they were mechanically very clever, but very obviously made as toys. Water pump on the other side was used in temple fountains. And Hero also went out of his way to explain that he was just intellectually playing here. He was not actually doing worthwhile things. Now, why might I blame that for some of the technological ignorance? There's a legacy of that in our, at least, educational system, and I think it was preserved for us by England and then imported. In the sense that Oxford does not have an engineering school, and Harvard does not have an engineering school. And in fact, when engineering schools were started, it was the first engineering school in the country was at West Point. They were started because the universities did not include them. And I think there's still a remnant of that in kind of the intellectual pecking order of at least countries with English inheritance. I can't prove that, but I think starting about back here, it became almost if not okay, to not understand technology, because things like politics and philosophy were of a higher level. Anyway, let me go on a little further. Lots still happened. The Dark Ages weren't really dark. Historians are now figuring that out. There was tremendous progress in a lot of things. And there was an agricultural revolution along about the 800s or 900s. And in medieval times, progress kept going. Cathedrals, 12th or 13th century. And once again, these are to help things that people do. If you're going to be a devout worshiper, a Catholic, cathedrals help. Gadgets, machines. And once again, the message I'm trying to make is technology is now going along, becoming more and more complex and profound, but it's subservient to the way we live. Now, sometimes people call this the craft period, if you would. These kind of machines, you can look at them and see what happens. Here's a screw jack, and you turn that, and it goes up and down. Once again, no PhD needed. Then an interesting thing happened. The Renaissance, Leonardo. And then a lot of people like, this is a steam engine made by a man named Savory in the 17th century. Now things are changing a little bit. Now all of a sudden, mathematics is starting to enter the picture. And this makes it harder for some people to understand things. Theory is starting to enter the picture. Esoteric jargons are starting to enter the picture, and complexity is starting to enter the picture. Even that you can't sit down and whittle out of a log. And in a way, we're getting to a new age, which was probably epitomized by the Industrial Revolution, where now all of a sudden we have a technology that's not only complex, but it's oriented towards a whole new purpose. In this case, the production of stuff for people. And now technology is having an impact on the cultures themselves. And this period is called by some people technocracy. And the reason it is because before the Industrial Revolution, there was no 8 to 5. And now all of a sudden we have factories, we have mill towns, we have people who have regular working hours, and we have a lot of industrial cities that are essentially oriented towards serving the technology. So now, instead of all these things that help us in our usual form of life, we are altering our form of life in order to get what we want from technology. This has continued for some time, but the difference between these two periods is really outstanding. One thing that's, clocks started to become very popular in about the 14th century, the late medieval period. And all towns had a clock in their tower, and wealthy people had a clock in their house. But one thing that I sort of like, and it's sort of marvelous, is that they were all different. In other words, your town just figured out what a cool time it was, set its clock that way, and ignored the fact that all the other towns were different. Now they all set their clocks the same way. When the Industrial Revolution came, there was obviously economic benefits from adjusting clocks and for standardizing. This was the famous showstopper at the Crystal Palace exhibition. It's a Colt revolver, and it was demonstrated in a whole bunch of bushel baskets, each one of which was full of a particular part, and the people who went to the show could make guns out of taking a part from each basket, and they all fit each other, and they were standardized, and this was big. So industrialization continued in this direction. Then what happened? Well, there's a third stage, and a book by an interesting man named Neil Postman just came out, and the title of his book is Technopoly, and that's what he's referring to as this third stage. In this third stage, technology sort of began doing things that people found it more difficult to understand, and people quit questioning its effect. One early thing that Postman points to was Ford. This is what happened in 1 year to Ford production, 1913 to 14. I don't know if you can see it or not, but that top number has, that left column are the number of minutes it takes to assemble various things. But take the engine. In what they call late craft production in 1913, it took 594 minutes. When he put in his assembly line that year, he reduced the time to 226 minutes. So, as you can see on the right column, the amount of effort required to make things dropped sharply. 88%, 83%, 75%, 62%. But there were other things happening. Have you heard of scientific management? Taylor, these people? At the same time, people were trying to figure out how to make people better components of a machine. You've seen Modern Times by Charlie Chaplin? It's a sort of a tongue-in-cheek criticism of that period. The people were being asked to accommodate to the production form. And life was once again becoming more and more dominated by technology. Now, I'm not telling you this with a value attached. I'm not saying it's bad or good. I'm just saying it happened. And it's very important, I think, in understanding technology today, because so far I haven't shown you any nuclear reactors. I've showed you a sequence that, as I said, started out flat, and then at some point, only maybe 100 years ago, started coming up steeply and started very much affecting the way we live. Now, 100 years out of 2 million years is not a long time. And I think we sometimes, and this has something to do with creativity, I think people sometimes have too high of expectations about creativity. It's not that easy to change that fast. I have a favorite question I ask people when I'm talking about creativity. I'll ask you, how many of you think it would be nice to be a little more creative? Individually. Most people will say yes. Think a little bit about what that might mean to you. What would that do to your life? Well, you might become fabulously wealthy and very well known, but it would do other things. You'd have more uncertainty in your life. You might make more mistakes in your life. Your friends might worry about you more in your life. If I may use the term, I think there would be more hassle in your life. Now, my next question is, how many of you are looking for more hassle in your life right now? And there, I'll see you later. See, there's a dichotomy there. And in fact, I think people really like to think of change, but I don't think societies change very rapidly. And I think by maybe this time, technology was moving fast enough to put a little stress in society. They were trying to catch up with it. Now, since that time, the ante has increased. Many things have been changing. And let me talk a little bit about that. Let me talk about the changes that have occurred in the last, 50 or so years in technology. Here's a little chart. Changes in the workforce from 1880 to 1980. That solid line is agriculture. So you can see in 1880 there was almost half of the population involved in agriculture. Now it's about 3%. Very rapid change. The line, I don't know what you'd call it. There's a sort of a funny jumpy line around there called industry that started out, maybe 16%, went up to about 40%, jiggled a little, and is now dropping sharply. In fact, I think in the last 5 or 10 years we've lost something like 10% of the manufacturing jobs in the country. And there are a lot of people who feel that it's going to continue to happen. Service kind of goes up, and then information goes way up, because I took this from a document that was promoting information. However, one of the things that's changing is engineering in the country. Certainly, manufacturing is not anymore the primary thing that technology does, and a lot of the things that technology does are less accessible than they used to be. Software, for example. Not everyone feels confident that they can understand software the way they think they could understand a screw jack. Electronics, genetics, recombinant DNA. These things are quite abstract. They have concepts that take a lot of study to get used to. And so one thing that's happening is that we're going from things like manufacturing, putting stuff together that's physical, into some areas that are much, much more intellectually opaque for most people. And one of the results of this, I think, is a lot of people have stopped trying to understand what's going on. I'll give you some other things that are changing. Our place in the world. This is the Japanese share of the world motor vehicle production. Probably seen this sort of a thing. From 1955, when they had a negligible amount, to this one goes up to 1989, when they were pushing 30%. Now, this kind of change has also caused some consternation in the country, because many of us kind of had our values formed in the World War II and beyond years. And as you probably know, in World War II, you may not know, but the GNP of the United States tripled, and the GNP of most nations that competed with us industrially was trashed. So from a period about 1945 to 1975, we had a pretty easy time economically. We almost had a monopoly on the world economy, and we had almost all the automobile production. So one of the things that's happening now is all these other people are taking away our monopoly, and this is changing very rapidly, and it's muddying the waters as far as what our role is in the world. The whole international base of technology let me show you a couple other interesting charts here. This is a chart from a paperback called The Machine That Changed the World, which is about the ascent of Japanese automobile manufacturing. And you don't have to read the whole chart. Over on the right, those 3 bars have to do with really the developing economies. The one on the left is the best, the one in the middle is the weighted average, and the black one is the worst. The one on the left is the same three figures for Japan, and this is a measure of quality. And what you'll notice is the best plant in the developing countries is better than the best plant in Japan. It happens to be the Hermosillo Ford plant in Mexico. It has the highest quality of any car assembly plant in the world. Well, hey, you know what's going on here. So the whole global thing is becoming complicated. What other changes do we have? Engineering as a field is changing. When I went to school, we got charts like this. And they're even alphabetical. This is from the Standard Occupational Classification Manual of the Department of Commerce, which still uses the kind of charts I had in school. And it says aerospace, agricultural, chemical, civil, computer, and electrical. This is a chart that I just got from MIT, the total enterprise approach. And it says things like customer marketing, community administration, government product, vendors, supplies, and operations, but even worse, they're all overlapped and interlocking. So what's happening in engineering is that people are having difficulty now separating things out because all functions seem to be overlapping. You cannot, if you're in your right mind, design anything mechanical anymore without a microprocessor in it. And this is a very big change for engineers, at least, because one of the hallmarks of a mechanical engineer used to be an allergy to electricity. And this is no longer a possible thing. What other kind of changes do we have? Well, you've heard about the conversion from defense business to civilian business. Now, you know, nobody knows what the end item of that. One of my friends has spent, I haven't seen him for a year because he's been over in the ex-Soviet Union watching it to try to convert from defense to commercial sector, and it knows it's going to. So it isn't kind of waiting to see what happens like we are. But this was a 1989 chart, and it shows the research and development breakdown in government expenditures, and you can see that out of some 61 billion, 40 billion went into defense. Now that may change. In fact, it is changing, and that will cause other uncertainties. Now what I'm trying to do here is portray a picture of this progression of technology through time, which not only has been speeding up sharply and affecting the way we live, but which is now in tremendous flux. And in fact, we don't know what the answer is finally going to be. We also have tremendous variety. I'll show you a chart of the gross national product, just to show how global I am. And the interesting thing here is that we hear a lot about communication, we hear a lot about electronics, we hear a lot about integrated circuits, microprocessors, but the whole mess, electrical things, and you can even throw in motor vehicles and a few other things, is very much smaller than construction. And if you've been following the newspapers, the big worry that people seem to have these days is the infrastructure. Apparently we have a $3 trillion bill looking at us to fix the roads and the bridges and the highways in the country and find out which pipes are leaking and fix them. I mean, places like New York City are approaching Mexico City. One of the reasons Mexico City has a problem with their water is nobody knows where the pipes are and they're all leaking. And New York knows where some of the pipes are and only some are leaking, but to fix that is a huge bill. Well, we've been putting so much emphasis on so-called high technology that we've kind of forgotten that our technical requirements are really spread out a lot now. They go all the way from recombinant DNA to sewers. A couple other things that are very much a sign of the times. One is a lot of social confusion. We have tremendously high expectations of technology, probably because of the success of marvelous things like the Apollo project and so on. We seem to feel that if we spend enough money, we can have anything, no matter how complex it is, and that it will work the first time. You've seen a lot of that in the debate on, well, for instance, SDS, Star Wars, where a lot of the technical people say, hey, give me a break. You know, if you build something that complicated, the chances of it working successfully the first time are very low. But on the other hand, there is an overwhelming feeling, and it's reflected in the government, that if you just spend more money, you can do it. So there's tremendous faith in technology and tremendous expectation, and also tremendous impatience with failures. Another confusion can be seen in the date between the free market approach and government policy. And that's very strong in our area because a lot of the leaders of the electronics industry, which is very strong in our area, are very free market people. They really believe in business, but they want help. And so there's a kind of a debate on whether we're going to keep the government out, which is the core of any good free market business person, or whether we're going to do something about those Japanese through some kind of national policy. A confusion. What other confusions? A very heightened awareness of the unexpected fallout of technology. It's not a secret that if you develop something with great power, there may be things that happen that you didn't want to have happen. I think our awareness has gotten so high of that we've become almost timid. And once again, that may not be good or bad, but it's a confusion in the sense that people are debating long and loud about it. So we've got complexity, we have a changing base of engineering, we have confusion, we have very broad variety, and finally, back to ignorance. I found it very interesting when the Challenger blew up. And it was admittedly a very tragic event. But I had spent a good number of years in the aerospace industry, and they were kind of traumatic years. I went to work for the Jet Propulsion Lab in 1959, which was kind of Sputnik time. And, you know, we heated to the moon with John F. Kennedy. And gloriously, we had responsibility for the first moonshots, which were the Ranger spacecraft. And we unerringly placed the first 6 in the Atlantic. Now, we were trying hard. And we thought we were pretty smart. It's just nobody done it before. So it seemed pretty hard. We were rewarded for our unfailing experts by a congressional investigation, which concluded that we were incompetent. But I guess because of a lot of that in my early background, I sort of really subscribed to the fact that if you try something you never tried before, and it's very complicated, it may go in the Atlantic. Now, maybe partly because of that, when the Challenger disaster happened, I was called by some of the local press people. And they asked me what I thought about it, and I said the wrong thing. I said it was a complete tragedy. And I said it was a complete tragedy because those wonderful people were killed in this explosion. But I said I wasn't really that surprised. And the reporter, sensing action, you know, I could hear the quickening of the recorder, said, "Oh." And then I went on to say, yeah, I said, it's a miracle one of the others didn't blow up. Okay? Now, I sort of believe that. I guess it sounds callous, but the space shuttle is a very, very ambitious technological tour de force. And, of course, one reason it's interesting is I think one of the reasons that people are so fascinated by it because it is dangerous. Now, technology is very symbolic to us, and I think that when something happens like a Challenger failure or 3 Mile Island failure or something, the nation as a whole really gets its feelings hurt. There was an investigation, as you know, and the result of that investigation was one of the truly most readable documents that I've ever seen come out of an investigating committee. It goes into great depth, and it's written in very good English. And what does it conclude? Well, it first of all discusses what happened. And as you probably know, the space shuttle has large strap-on rockets that are made out of solid propellants. And they're made in sections, and the sections are put together, and the propellant is put in place, and at the right time they're ignited, and away they go. And this was the source of the famous O-ring failure. And O-ring, therefore, is in the title of my book. An O-ring's one of those rubber donuts that's in your sink faucet. Now, can they fail? Have you ever watched your sink faucet? They can fail. There's a double O-ring in the original shuttle design, and there's a lot of packing around it to keep it from getting overheated and so on. But, of course, what happened in this was that the launch temperature was very low, and therefore the O-ring had lost some of its resiliency in the opinion of the panel, and therefore was not elastic enough, and it allowed the flames to leak from the joint. The flames then impinged upon the liquid tank blew up, and the disaster occurred. In the report, they do at the end say that the joint should be fixed, but they blame a lot of other things. See, it was not unknown that this might happen. This was a recommendation a long time ago that was written, well, it was actually written by the chief engineer of Thiokol, the developers of the rocket. And it says, recommendation, O-ring temperature must be greater than or equal to 53 degrees Fahrenheit at launch. It was about 35 degrees. And then it goes on to say other things that didn't happen. Now, people knew it should happen. Why didn't it happen? There is, in any complicated project, an organization, and the shuttle organization looked like this. There are contractors that make various parts of the engine, and then there are NASA centers that monitor those contractors. And when a launch is to be made, those contractors each worry about the health of their component, and then the component health, if you would, is relayed to the responsible center, and then it goes into what's called a pre-flight readiness review, and is essentially filtered through to the mission management team. Now, there are a lot of parts in the shuttle, and there are a lot of people in this process. And what happened in the shuttle launch is the word didn't get through. And one of the main recommendations of the panel is that the organization should be redesigned, that there should be more fail-safe mechanisms built into this, not the O-ring. Well, people have difficulty with that. Most people that I talked to right after the explosion figured that the reason the shuttle blew up was some incompetent engineer that made a poor O-ring design, which may have been true. But what I think they didn't understand is the complexity of an operation such as this. It would be nice if we never had failures. And when we do have failures, to the extent that there is some kind of criminal negligence, it certainly should be punished. But we just don't seem to understand where we are as far as this technology is concerned. And I guess when I'm talking about ignorance, that's the sort of a thing that I'm talking about. Not that people should be able to build a shuttle, but they have a sense of the risk that's being taken and a sense of the control that people have over the final result. So that was the last thing I added to our cake of where's technology right now. It's growing very rapidly, and not only has it become confusing and hard to talk about, but there's a kind of an increasing, I think, general ignorance. Now, that's been recognized too. About 10 years ago, there was much talk about technical literacy and scientific literacy, but unfortunately, talk like that dies out pretty rapidly, and it takes a long time to have an effect on a population. There was a lot of action at the time. There were a lot of foundations putting money into it, but then people are off on other things now, so it's kind of died out. Now, why do we care? Well, let me talk now a little bit about the future. Now that we're in this kind of very fluid, dynamic state where a lot of things are up for grabs and unknown, what's happening in the future? Well, let me just take one example of something that's happening which is pretty clearly predictable. And I just want to talk a little bit about information. You've heard about the information revolution. We are definitely in the information revolution. As most of you have read, we're a very few years from having access to 600 channels of TV. Now, one reason you read about that is people aren't sure where the programming is going to come from. You know, apparently a large amount of this is initially going to be used on things like the half-hour commercial deals and stuff like that. But we're going to have an explosion of TV. The other night at dinner, I was sitting next to a man who, at one point, after emitting beeps, flipped his flip phone open and started talking. And he was younger than I was. And afterwards, I sort of subtly asked him if maybe he didn't think it was rude to talk on his phone at dinner. And he subtly informed me that, in fact, it was rude to not be accessible. Different style, but a lot of people like that. I was on a consulting job recently to Motorola, which is in Schaumburg, Illinois. And I don't change time zones easily, and that's only 2 hours. But I flew back there, and I was to meet another person And this other person, I couldn't catch him on the phone. All I could get was his voicemail or his email or something. And finally, we communicated enough to say we should meet at breakfast. Well, breakfast at Schaumburg was 6, which was 4 o'clock Pacific Coast time. So I sort of struggled down to breakfast with my shirt buttons almost aligned and almost shaven, feeling generally sorry for myself. And here was the world's most immaculate person, sitting there with proper power shirt and power suspenders and natty tie. And he was going like that. He had a little roll-away thing, and on the bottom of it was his leather underseater. And then on top of that was his notebook computer. And then there was his modem. And then here was his cellular phone, and on and on and on. And he's doing his computer and doing his phone at 4 o'clock in the morning. So I said to him in order to make conversation, gee, it really looks like you like electronic communication. And he said, oh my, yes. And his story was as follows. He's a member of a 12-person consulting firm. And they found that they've traveled so much and used so much communication technology that they got rid of their office. So now this is a virtual office, as it's now being called. And these people are simply doing business over this kind of media. Now, the next thing that happened, though, and this one really took my breath away. Now, this guy's not married. I should tell you that. But he thought this worked so well that he got rid of his house. So he doesn't live anywhere. I mean, this to me is mind-blowing. When he's not traveling, he sort of picks some place he'd like to be and goes there, and he has clothes stashed in various hotels. He pays them something to keep him there, and the guy's in orbit. And I thought, my God, this is the wave of the future. The only way out is to kill myself, because I don't want to do that. But this is the information revolution, right? And it's happening. And you know it's happening, too. If you are in a situation where you have to communicate with other people, you've probably noticed how often you can talk to a real human on the phone. I mean, we've simply gone into a whole other mode of handling information. Now, at the same time, the amount of information is increasing. Why is it increasing? Whole number of reasons. Digital circuitry, as shown in the integrated circuit, has been improving at a very high rate, exponentially, for a large number of years, and will continue to do so. My friends in the integrated circuit business see no reason. You can now make an integrated circuit with about 1 million active electrical components. And they see no reason why in 10 years they can't go to 1 billion. It starts tightening out up there because conductors become about 8 atoms wide or something, and nobody knows quite what that means, but it's going to continue. Now, during that time, unfortunately, the human mind has not improved. So we're getting a mismatch between the information that's out there and us. Here's an interesting set of numbers I took out of this Postman book. This is us. It's what's going on right now. We've got about 250,000 billboards, a little over 10,000 newspapers and periodicals. You can just look down that list, you'll love the end. There's 60 billion pieces of junk mail a year floating around in the U.S. It's a lot of stuff. How do you respond to that? You throw it away, mostly. Now, Postman in this book, Technocracy, makes an interesting point. He looks back at our 2 million years of life and says there wasn't much information there. He even looks back at people like me and some of you, and he says, hey, when people like me grew up, lots of things happened. First of all, information was written, and it took a while to get to you and a while to read. Some was on the radio, but mostly it was in written form. Secondly, there were many agencies that limited it. For instance, your parents decided what you should know. And, you know, to people my age, this included nothing about sex, nothing about death, nothing about money, nothing about all these things. And there were churches who further decided what you should know and what you shouldn't know. And there were a whole lot of people that essentially limited your knowledge. Now, what Postman's afraid of is that if you submit too much knowledge to people, a couple things happen. First of all, they kind of give up, which is what I do with junk mail. I don't even sort it, I heave it, because it just is overwhelming. And I probably throw away all kinds of really hot deals, but I just can't do with it. The other thing he says is that we live a tortured life because we're so aware of so many things going wrong all the time. You know, what's happening in Somalia? You know, what's happened to the poor students in Tiananmen Square? We just simply have a list of things that are wrong, that people didn't have 50 years ago. The information thing is a good example of something that's now going, that's really changing the fabric of the society. We have been print-based for about 300 years, and education, among other things, is print-based. It's based on the book, and you treat books in certain ways. You can read them at your own speed, and you can read them deeply, and you can read them repeatedly. Now, is that true of modern media? I did an accidental experiment last year that was really sobering. One of the courses I teach is called Technology and War, and it has to do with the relationship of technology and war, which is another interesting thing. The military has always loved technology, and in the process of adopting it, keeps obsoleting what it does. It's essentially now made war not fulfill its original intention, in fact, not even made it much fun for anybody. So the military technology has now been to the point where it's developed to the point where you can't even use it, and if you could, forget it. And the contrast is really amazing. I was visiting the Air Force Academy recently, and they have pylons in the parade ground with fighter planes on them, single-place fighter planes. And I said, hey, why no missiles? And they growled at me. And then I happened to notice a parade. Air Force cadets wear white scarves, white silk scarves, which were originally used so you could look for von Richthofen without scratching your neck up. And I said, gee, it's interesting that your cadets wear scarves so they can look for Fokker triplanes. And I got another kind of frown. But there's very clear, I mean, I was in the Air Force. I know what people want. They want one-on-one glorious stuff, which you don't get anymore. Nobody's seen an enemy in a very long time. So this information stuff is going in the same direction of that. A lot of people feel that the age of print is over. And this is a very, very controversial thing. When print came in, there was a lot of opposition to it because of the fear that it would degrade memory. It is true that things like the Odyssey and the Iliad, the Homer epics, were carried from village by village by people who knew them, who had memorized those, not commonly done by present students. Because once you have the book, you don't need to memorize it. Now, the good news is you have access to a tremendously larger amount of thing. So we think that books are better. We wouldn't get rid of print and go back to memorizing things. There was resistance, which lost, and it's the same kind of resistance that's being shown now against electronic media. My experiment in my Technology and War course was I had assigned 4 movies that happened to be very powerful movies about 4 wars that were in the textbook I use. And for a final, without thinking much, I asked them students to compare the treatment of a certain battles in the movies with the same battles in the textbooks. And what did I find out? What I didn't want to find out. They had frame-by-frame recall of the movies and none of the book. So I'm convinced that our students right now are really visual keyers as far as the way they retain an information. And I think they work in sound bites. And they're not alone. I was fascinated, you know, flying up here, United. I pulled out my mag and I read it, and you've all done that. And those airport magazines are in sound bites. You know, in-depth articles, 3 inches. Time magazine just followed U.S. News. Now, Time never was the definitive, deep analysis magazine, but they used to have whole-page articles, you know. And now they have these kind of things. It's very possible that electronic communication is resulting in a different type of thinking style, problem-solving style, cognitive ability, and we aren't doing anything about it. We're not even saying that's great or that's lousy. Now, I attribute a lot of this to the fact that the public has kind of signed off worrying about technology and has allowed it to be kept by essentially engineering and business. And engineering and business have very different motivations. Engineers are gloriously idealistic and amazingly thoughtful and sensitive, but partly we engineers are in the game because it's fun. You know, that's a blunt way of saying it, but it's fun to make things go faster, so on and so forth. Business people, who are equally idealistic and so on, do think about the bottom line, especially at the higher levels, because if the bottom line slumps, your history. So I think there's an increasing need for public concern about what technology is doing to us. And it's a messy process. You know, I hand you timber. I mean, there is a public debate going on here now about what to do with timber. Not much on information. And that public debate is not possible unless the electorate and the elected representatives are reasonably comfortable with the nature of technology. Now, we're going to have a question and answer session later, so you can attack me on that if you can disagree, and I hope some of you do. But I believe it strongly enough that I've kind of complicated my career by going into the strange pastime of trying to communicate what engineering is to non-engineers. There aren't many of us doing it. Most engineers don't really feel that that's their calling, and it's very difficult, partly because a lot of people do have what are sometimes called math blocks. And there is some mathematical content in engineering, although it is not that necessarily profound, that needs to be done. What do I think should happen in the future? Well, one thing I think is that schools have to become more active at giving people a general realization of what technology is. And I'll sweep science into that rubric. I talk about technology because that's what I do. For some time now, people on the technical side have been told strongly that they're not much fun unless they have some minimal exposure to the humanities and social sciences. In fact, strangely enough, in the engineering accredited process, there is some amount required of that. I went originally to a school called Caltech as an undergraduate, and we were taken up for the mountains in a whole week, and we were told how to be human. And we were told things like, under no circumstances ever say anything mathematical in a party. And, you know, it was then slide rules. And we were told, everybody thinks you wear your slide rules on your belt, don't ever do it. So we were kind of given a how to be cultured talk. We were told the difference between sherry and port. We were told a little list of things to say about paintings, like subtle, interesting, and so on and so forth. And then we were exposed to a pretty good humanities program by some very dedicated teachers. Now, the opposite has not been true. If you look at students in most universities, including ours, the most broadly educated, strangely enough, are the geologists, because they have humanities, social sciences, engineering, science, and so on. The least broadly educated are the humanists, because they largely study in the humanities. They take very little outside of it. I think that it's time for a change. I think part of life is technology and science, and I think that people should think about it, and there are problems. There is not a lot of accessible course content. Most science and technology courses in most universities are pretty opaque, and they're pretty difficult to approach. I think that's solvable. That book was the hardest book I've ever written, and I'm not totally happy with it, and I think I could do some better. But I think it's possible to explain technology and science. There are a few good writers that do that. Anybody ever read a book by Tracy Kidder called Soul of a New Machine? Excellent read that tells you about it. John McPhee's pretty good. So there are a few writers who are very good at doing that. I think there need to be more. Another thing I think is that the engineering profession, including people in technology-based business, should take more responsibility to explain honestly what they do to people. Some people in technology have really shot themselves in the foot by not doing that, by assuming that people would take things for granted, and when they didn't, being essentially put out of business. A good example is the California nuclear reactor business, which is to simply assume that everybody would know that nuclear energy was wonderful, and we're shut down completely and haven't quite figured out why yet. The answer was, to the extent that they had a good case, they didn't put any energy into communicating it. I can pick on the media. And I really like media people. But media people like gee whiz stuff and doom stuff. You know, they like articles which are, you know, that there's a new drug which will let you substitute an ear for a heart or something like that. Or now they like extinction through meteorites. You know, that we're going to be wiped out by an errant asteroid and so on. There's less, partly because it's probably less good press, on just kind of what's going on. So I think the media needs to take a bigger responsibility in this education thing. Finally, there's got to be an international forum. There's hope. We're actually doing something about ozone on an international basis. But ordinarily, we're at a standstill. You know, we say, hey, Brazil, quit taking those trees down. And Brazil says, guess what you did when you first settled this country? You took the trees down. And there's no debate. There's no tribunal. Acid rain, all these things do not have any sort of an international basis that they can be figured out. So I think we need that too. So I think there's some things that we need to do to overcome this kind of ennui, and I'll call it ignorance about technology, and I think they're doable. We need to get over this two-culture thing. When I went to school, and when some of you went to school, the one way to be cute if you were a woman is to be a math boob. And one way to be macho if you were a guy was to not do poetry. Hopefully that's gone, and it is among the present students, but I think it should go away still further. It's not now gender-based. The enrollment in Stanford math courses reflects exactly the enrollment of men and women in the university. So it's not now the case. And you probably know that. Any of you sort of anti-math mothers who have a real math tiger for a daughter, and you sometimes find yourself torn between pride and worry, kind of, that's kind of gone away. But you see, now what we have is a non-gender-based split between the techies and the fuzzies, and I think that has to go away. The other thing is I think we have to get over being simplistic. I'm amazed by the debate that goes on about whether technology should be controlled by the free market or by government policy, and it's always an either-or thing. It's never been either-or. It's always been both. And we have to quit this funny argument about which it is and figure out what the right combination is to do it. Government intervention in technology is not new. It started when the best way to make money was to have the fastest steamboat on the Mississippi, which resulted in a huge rash of steamboat explosions right after the Civil War. And the government at that point set up its first control, which later reduced steam engine explosions. And you know, we're talking 100 years ago. Since that time, the government's gotten more and more involved, as in safety, environment, and so on, but that's not new. Neither is the commercial control on technology, and clearly we got to figure the whole thing out. Now, am I a pessimist? No, I'm an optimist by birth. But one nice thing about this country, at least, is that when it gets confused enough, it slows up. And we've been doing that with technology. Nuclear energy worried people enough that it was slowed up. Lots. You know, in science, I don't know if you've heard of the Asilomar conference, but when the first people to do biochem experimentation with DNA worried that maybe they were going to build a bug that would kill us all, they stopped. And they all went down to Asilomar, and they stopped until they'd convinced themselves that the likelihood of doing that was negligible. And they started again, but they did slow up. We slowed up on the SST. Often we slow up through anti-technology moves. I'm expecting an information backlash pretty soon against computers. Are any of you sort of thinking that might happen? Computers have been overbought in the sense that a lot of people have made big investments in them, and life is not measurably a lot better. And people are still have faith that it will be. And I'm incidentally pro-computer also. But there's a man in our area who's a very thoughtful man who runs a company that does not produce computers, who claims that everything's fine because the ultimate basic use of a computer is as entertainment. That we lived okay without them, but we're really having more pleasure in what we do now that we have computers. And he says everything's cool, that we'll just keep using our computers. But on the other hand, I know a lot of institutions like Stanford University that's invested heavily in computers, but it has more paper than it used to and more employees, beyond which no one can find anybody. And it isn't the computer's fault, it's the fact that we have a complicated organization that just buys them and doesn't learn how to use them. We're like many organizations in that information flow used to be, once again, controlled by things like how many secretaries, how many filing cabinets, how long inter-office memos stop. We got computers now, but we haven't rethought who needs to know what and how fast. But these backlashes tend to slow things down also. So I'm an optimist that we'll figure all this stuff out. However, my prediction, as I said earlier, is that we're going to need an increasing amount of creativity, because now we're not only trying to figure out devices, but we're also trying to figure out the device in a social context. You know, this funny program that I'm a member of, Values, Technology, Science, and Society, studies that. There are about 120 such programs in universities in the country looking at technology and science in the social context. They're all guerrilla operations, because this kind of a thing doesn't fit in standardized curricula. But they're all fairly healthy as far as student involvement and interest is concerned. And they're all devoted, once again, to figuring out what all this is. Now, what have I said to you? I've said that there are two cultures in the country. Postman, incidentally, the man I've been referring to in the Technocracy book, says the two cultures are technology and everybody else. Snow said they were essentially quantitative and non-quantitative people. They're still alive at Stanford, and they're orthogonal to understanding technology. And as I told you, there's some costs to that. Now, why is that a problem? Well, I ran you through a little quick technological history and tried to make the point that as technology was evolving in complexity, there were some very different things happening as far as changing the nature of it. At first, it was craft-based and adjunct to society. Then it became more complicated and, in a sense, had an effect on the structure of society, Industrial Revolution. And then it became essentially dominant in a lot of the things that we do. And essentially, we started accepting it without that much question. And now we have a situation where not only is technology affecting us heavily, but it's in flux. And I gave you a large number of reasons of what's happening. It's changing very rapidly. It's getting much more esoteric and less accessible. It's causing a lot of social confusion. It's causing a lot of uncertainty. And finally, it's causing a lot of ignorance about what's happening. Then I gave you an example of ignorance in the response to the shuttle. And I'm not saying the society should think the shuttle explosion was good. I'm just saying that they should have more understanding about why that things happen. And then I went on to suggest that what we need to do is to do something about this, and that's very doable. Now that's kind of my sermon. And that's a fairly short sermon, but on the other hand, I'm hoping to get some conversation going about this, because I think it's an issue to everybody. The creativity part's soluble. We have learned much more in the last 50 years about how to manage creativity, how to increase creativity. I think what's necessary is to kind of get people to be behind the movement, if you would, and the movement itself can proceed. Now, as I understand, we're set up here to do a little bit of discussion as far as questions and answers. And I believe there are microphones in the aisles. And I believe also that you've been given an opportunity to write out questions. Am I right? Okay. Have any of you written out questions? Why don't you write out a question? And somehow those questions will get collected and be brought up to me. And in the meanwhile, would anybody care to step to the microphone and either say something or ask a question or disagree with me or what have you? Can we have a little more
Let's
light?
have the lights up in the auditorium and down on the stage so you can see us.
Okay, up above.
Have you read a book called Having Fun at Work?
This isn't Take Your Job and Love It, is it?
No.
No. No, that is the name of a that is the name of a book. No, tell me about it.
The author's thesis is that to get a complicated problem solved, you have to do it with a skunk works. You can't do it in a going organization or a traditional organization.
I've read a lot like that, and there's the truth in that is that we're getting into creativity now. I'm not adverse to talking about creativity. I just wanted to make my technology sermon. Organizations, as they grow, have an increasing control problem. In other words, if you look at a very large business, a lot of its energy is channeled into trying to keep it stable. And this is not always the best of all environments for creativity. So one approach to creativity is that you break out a so-called skunk works or a team. Everywhere you go now, people are talking about interdisciplinary teams and tiger teams and crash teams and so on. And you essentially relieve that team from the burden of the bureaucracy associated with the greater organization. And you select that team such that it works very well together and does a very good job. One of the classic examples of a skunk's work was the one that Kelly ran at Lockheed, that designed most of their swoopy military planes and things. That's having a lot of play. It does work. There are other companies, though, that seem to be very creative without skunk works. Good example is Hewlett-Packard, which is a $15 billion a year company with 90,000 employees that has an R&D lab, but not an official skunk works. What HP tries to do is keep the skunk works mentality spread throughout the corporation and to use a lot of kind of freely moving project teams and so on. So, you know, I have not read the book. I think that point's a very powerful one. I think it's one that industry is accepting and learning about. I think there are other ways to go than just a formal skunk works. More questions or comments? I can't see, though, because there are great bright lights in my eyes. Okay, down here.
Is this on? Yeah, apparently. What I was going to ask is, it seems like whenever there is either a great burst of creativity or some type of new idea to help technology, it's always pushed under the carpet by the people who are already using the existing methods or the existing ideas. As I've heard people say, usually everyone at first says it's impossible, then says it probably wouldn't work anyhow, and then after it starts working, they say they knew it all along. Is there any way that you can think of that we can kind of get around this type of situation?
Let me say that when I first got interested in creativity, I was very interested in techniques to cause people to have more ideas, and I still do some of that. But what I found out is that's not mainly the problem with most organizations. There's a lot of ideas there. The problem is that the more people you get, the more resistance there is to new directions. And if you get something like a society, it's really not very good at new directions. It likes change in the abstract. I thought the last election was very interesting in our area at least, because the overall endorsement was for change. Our area went heavily Clinton, but yet it voted down every specific measure that would cause things to change. So it was saying, oh boy, Clinton, new stuff, and then every time there was a bond or something that would let some of this stuff happen, it was trounced. So I think like individuals, organizations are ambivalent, and when you get into large organizations and societies, they're very suspicious about change. There are two things about that. When I do creativity workshops now, I sort of emphasize implementation scheming more than change. What I find, especially in technology-based organizations, a lot of people who have ideas do not know how to be wicked enough in a political context to get the thing to happen in the company. And the other thing I emphasize a lot is, you know, just kind of techniques of getting people softly on board as you go. But it is a great problem.
Yeah.
Maybe it's not. Maybe that keeps our society stable. You know, maybe we've got enough change right now.
Well, like you say, it's very complex when someone has an idea to protect the idea and to implement it, like you were saying. I mean, not only is it difficult once you've had an idea to patent it and to make sure that other people can't take the idea and
well, especially in some industries. One nice thing, say, about the electronic industry is you can start your own company within finite constraints, not so the automobile industry. But that's a wonderful observation. Who's at this microphone over here?
I'm over here. Maybe you can even see me now.
There, I can see you. I can see you better. Did these lights die? I guess not. Oh,
Eureka.
power. Yes.
When you showed the NASA organizational chart, and after the O-ring suggesting that maybe redesign of the organization was at least as important as the physical engineering, it sounded like maybe engineering is beginning to feel that design of large structures and lots of people is becoming an engineering job, not a fuzzy but more of a techie. There's a real discipline shaping up here. Maybe that engineering can feel some ownership of that. I was wondering if that was what, you had some hope for that.
Yeah, there is a new discipline shaping up.
Like cybernetic something?
Well, there's a field called engineering management that a lot of schools are getting into. I was over at Oregon Graduate School. They're starting or trying to figure out how to start a program such as that. And there's a lot of activity in engineering schools on, system thinking.
And what would follow from that is, do you feel like take nuclear energy, that if you're an engineer, you can look at a design and sort of feel if it has integrity or not? The same might apply to looking at an organization. And do you feel that the organizational structure behind what's happening with shipping plutonium, say, to Japan right now, do you trust the organizational structure behind that, or do you think it needs to be assessed a little more before it's given the green light?
I trust myself to know whether there's a hand grenade there. I don't think I'm the best person in the world as far as designing organizations. And one of the nice things is that business schools and engineering schools are moving together. I think organizational design needs to be done by a combination of people who kind of understand the end product and people who understand the structure of organizations. But there is a new field in that direction. Over here?
Following up, a question that's kind of similarly related to the previous discussion, do you think government and politics and the social fabric of society will change that would encourage government intervention to kind of govern the role of the organizational structure to determine whether or not there is adequate organizational structure and control? For example, in nuclear engineering, people have argued that the technology would be okay if there were sufficient organizational controls and safety provisions there, and if society knew that government was there backing it up. Do you think we will move in that realm?
We could, but it would require a change in the cast of characters. Right now, the private sector does not give a lot of credibility to the government's ability to manage projects and vice versa. We are led to believe from reading the newspapers that there was tremendous waste in the government sector in all these areas that were privatized during the Reagan administration. Now we're being told that, in fact, the private agencies ripped off the government. So there's a little India here, where business and the government doesn't quite respect each other's ability. If we reached a place where people in the government were respected, I think, and good, it would be an interesting thing. I'm not sure that'll happen. I don't think the government of this country will get involved in those organizations. And I guess I think that it's now constituted, that's probably okay. Up there.
I was wondering if you have any specific predictions about how we as a society are going to be dealing with the overwhelming amount of information we face every day.
The overwhelming amount of what?
Amount of information that we're dealing with more and more.
Yeah, we're going to have to learn to sort it. We've taken one step, which we've kind of gone a long ways towards making everything available to everybody.
Are there specific technologies, do you think, that are going to help us deal with this?
No, I think we're going to have to develop them. And I think what we're going to have to do is to get a lot smarter about how individuals process information. And that gets back into creativity. People aren't quite like they say they'd like to be. A lot of people are like me. I write books. That's supposedly creative. I hate to write books. I mostly like to have written books. So what do I do when it comes time to write a book? Well, usually the first thing I do is I overhaul all my cars and paint the house, okay? And then after that, I pick up a new interest, you know, like playing the police whistle or something like that. And in fact, I'll do anything to avoid writing my book. Now, what do I do at work? I read my email. I listen to my phone mail. You know, I review my voicemail. I look at my mail. So I think what we don't realize is that a lot of us use information to escape creativity, if you would. And I think we have to face that and then start thinking through these things. You can have a wonderfully full day just reviewing stuff. You know, our university budget's online, and it's fun because you can tell how much money all your buddies have. So I was reviewing the budget the other day, and I thought to myself, what the hell am I reviewing the budget for? You know, it has nothing to do with my job. It's just there, and it's easier than grading papers. So I think we have to take a long look at some of these things. Down here again.
When are you going to start teaching technology to engineers?
Oh.
Let me continue a second.
I know exactly what you're saying. Say the rest of it.
All right. All through the English-speaking world, engineering curriculums are almost identical. There's lots of calculus, lots of math, lots of science, but no design. There's almost no design. The education board calls for a certain amount of design. Something like 15% of the courses are design, but these are science courses. And then these engineers get thrown out into the world with no playing around with problem solving, creativity. It provides you with a living.
Well said. I happen to agree with you absolutely. I'll tell you why. I won't answer your question as to when. Engineering, for instance, in the 30s was really very much based on experience. And most of the relationships that you found in books were empirical. You know, you'd open a civil engineering book and it'd tell you that the flow through a weir was 3.87 times the cube root of 92 times the height or something. And that came because somebody went out and looked at weirs. A weir is a ditch. During World War II, there was tremendous success from technology based on science, as far as radar proximity fuses, the nuclear weapon, and so on. After World War II, engineering education fell deeply in love with math and science. And it's been very profitable. In fact, the highly mathematical and scientific education is almost essential now for a lot of things that engineers do. Unfortunately, it's very convenient to do in a university. It's a very, you know, you got journals out there, you get status. Going back to the Greek thing, mathematicians are kind of cooler than engineers. So if I do math, you know, I can kind of feel good about it all. And so I think that engineering are now reluctant to let loose of that. In the meanwhile, the faculty hiring and tenure requirements have kind of reinforced that. And if anything, the younger faculty are more theoretical than the older faculty. There is now a backlash towards design and creativity and so on, but now the engineering schools are hampered because of the evaluation processes that they've set up that are based on more theoretical work. Your problem is very real, and a lot of people are trying to deal with it. And I came to Stanford 20 years ago to do this. I was hired out of industry as a design advocate, and I've taught design. And I've tried it really hard, and I've had interesting little jobs, like in the dean's office and head of the advisory board, which looks at promotions and tenures, and I've been chairman of a lot of departments, and I've cheated and lied and stealed and, you know, everything else. I haven't had much effect. It's really deep-seated. Now, the good news is that Japanese educational system's worse. And, you know, that it's not only all over the Western society, but the whole world is like that. So as far as competitiveness, we may not be paying too much of a cost.
The architects have a paradigm.
Yeah, they do.
And it works. Their design studio,
yeah,
which integrates all their work.
Oh, hey, you know, come, I'll buy you a drink later. But studio is not a high caste word in the kind of university where I work. So the man is right, but it is a major problem. Let's go over here.
We've all encountered technological decisions that looked good at first but turned out to be bad. CFCs and autos are easy examples. Last year's engineering speaker suggested, among other things, that we need to integrate the equation more carefully to look for problems like that. But, and I agree completely, but these problems come out of left field. There's nothing, no term in the equation that lets you know about that.
Yeah. I think we have
can
to admit,
we-
I was going to write a book once, and the title was going to be Things Break and People Screw Up. And I believe that. You know, I believe that. I believe that there's probably a crooked pyramid because somebody read the prints wrong or something. There's error. And it's not only that. A lot of people feel that error is the basis of technological change. I think the first thing we have to do is accept that. And I think at that point, then we can, you must be talking about Henry Petrosky,
Right.
who tries to sell the use of failure as an academic tool. And the problem is people get squirrely about that. Students are hard. I just reviewed a manuscript of a new book Henry wrote that I liked a lot, but I had to put some cautionary words in there because he intends it as a student textbook. It's cases of old failures, aqueducts that fell down and so on. Well, first of all, to students, you know, the student's old as 3 years ago. One of the necessary things to do in the university is to keep calibrating yourself. You know, our freshmen are 18. They probably became aware of the world at 12, and that happened to be 1986. So our freshmen don't have much awareness before 1986. And one of the most tragic things is to, you know, a lot of the faculty were scarred by Vietnam. And it's very tragic to find people trying to get the students to differentiate between Vietnam and the Boer War. So one of the problems is to get students to use this. The other problem is that when students look at the Tacoma Narrows Bridge or something, their reaction, and I applaud them for it, is I wouldn't do that, you know. I mean, those dummies made a bridge that fell down. So I think the first step is to get some understanding. Now, there's a problem here, just like there is in most professions. Engineers don't brag about their failures. One of the main important parts of the engineering process is called development. Now, in mechanical engineering, that's because when you design things, they don't work. So you fix them so they work. But you do it very quietly. You know, you don't take videos. And you don't invite field trips of students to come in and see this thing that doesn't work. And really, technology, like a lot of areas, is caught between trying to get work and being honest. I think we have to get over that and be honest. I think, you know, if it weren't for the fact that most engineers work in companies, we'd have malpractice too, because I think we've oversold our abilities.
My question really is, knowing that these things are going to come out of left field, and knowing that as powerful as we are these days, the effect could be pretty nasty, how can we institutionalize, if you will, looking for these left field effects and dealing with them before they kill us?
Well, I think all you can do is sensitize people. I'm not convinced that we can ever get rid of error, at least judging by my friends. I have friends with resumes 60 pages thick that drink too much and hit garbage cans with their car, you know. So I think there's a human element in here, but I think it's a sensitization process. It's going on in some areas. I think it's worked pretty well in aircraft design. I mean, over time, aircraft have become safer, even though traffic has increased and so on. So I don't have anything other than, I'm really in favor of what Petrosky does, which is to keep rubbing people's nose in reality.
But it's not enough. It's not going beyond the
Okay.
engineering problems.
Okay, since I'm about to go upstairs, you tell me.
I don't know. I don't know.
I wish I did. I'll buy you a drink too later. Up there.
What kind of a high school student, a high school graduate, would you like to see coming to your university or to any university?
Once again, I'm sort of atypical. And I just talked to a bunch of high school students today. For better or for worse, you got to join a club. And what that means now in technology and universities and everything else is that you have to be able to add fast and accurately. You have to get your 3 R's down. You have to get through the SAT and so on. But I like people with devious minds. And by that, I like people who really want to know why things work the way they do. It's sometimes called intellectual curiosity. And I also like people who have enough self-confidence to try things that have not been tried before and don't get too broody when they don't work. So I'm looking for two things. I'm looking for people who've proven that they can play the game as society calls it. And I'm also looking for people who sort of have a love of finding out things and experimenting. You know, that's what I've always told my kids they should do. But yes?
Okay. What advice would you have for a young, undecided engineering major who wants to be both a techie and a fuzzy?
Do it. You want me to give you my standard litany? It'll take longer. What you'll find out is that I did it sort of accidentally because I always wanted to be a painter, but I didn't want the lifestyle. So I kept going to art school until I got a really hot job, and I go back and forth. And it's been invaluable. Beyond holding my own at cocktail parties, I think I not only have a pretty good feeling for the humanities and technical things, but I know a lot of commonalities, which is how I got instant creativity. The blank piece of paper is a commonality in all fields. There's an increasing market for people that can do both of those. And there are two problems. Not only does it take longer originally, but you're going to have to keep bumping up against people who only do one who are better than you in that area. But if you want to do that incidentally, you can't do anything else. You know, one of the ways that colleges, or we admit students, is on breadth of interest. And then we say, hey, you got to take a major, you got to specialize. And so, you know, students will come in and say, you're right, I got to specialize, I won't be interested in all these things. And I just crack up because you can't do that. You know, you can't all of a sudden focus your interest. So God be with you, be a techie and fuzzy, go to school a lot, and it'll pay.
Okay.
Over here. I've got some written questions. I'll get there in a minute, and I won't keep you all night either. Yes?
I'm a high school student. I'll be applying to colleges this year. Now, I've found that many teachers don't necessarily look highly upon mixing fuzzies and techies. In fact, I've been accused of being a jack of all trades but a master of none. Now, my problem is that I'm only in high school, and next year I'll be going to college, and you know, it used to be I had this image in my mind that I could, you know, kind of be a free thinker until I got to, say, junior year of college, and then I could find a major and go for it. But I found that everyone's pushing me to go one way or the other, and I really would like to find a system that would somehow allow me to incorporate different areas of interest, because I've always found math and science to be fairly easy subjects for me, and so I've decided to challenge myself by taking the more difficult classes for me, which were the humanities. Now, if I'm going to be pushed in one direction or the other, should I go for a strong point or a weak point? I don't know how to go for it, because you say that you look for students who have broad fields of interest, then you tell them to choose. Which way should they go?
All colleges do. Have you applied to us?
I spoke to a professor at your college over a bulletin board up here a couple days ago, and I think I will apply.
Apply to us. I'll destroy your life for you. I don't push people. What you'll find is an interesting and too bad thing. Schools with very large enrollment pressure, and that includes a lot of the really good state universities, will ask engineers at least to apply not only to engineering as freshmen, but to their major, which is insane. But their problem is simply that they're trying to screen people early on to get some kind of evenness in their enrollment. What you'll find is that private schools don't do that. We don't ask anyone to commit at least until they're their sophomore or so. But private schools cost more. And the one reason that we do that is not only do we figure that people should have something for their money, but we have a smaller group of people and more faculty, so we can do much more hand advising. Boy, if you want to be a jack of all trades, do it. Now, someday you ought to master one enough to sort of eke out a modest living. But I don't think any freshman has any reason at all to have any idea what they want to do in life, because none of my friends do. Okay, and I really believe in general education. One thing I even love to do with our freshmen, I talk to them before class starts, and I say, how many of you are sure you don't want to be an anthropologist? And most of them will put their hand up. And then I'll say, how many of you know what an anthropologist is? None do. So, you know, this is a whole crowd of people that have already made a decision made on no data. What you ought to do in college is look at a lot of stuff and then decide. So come to us. Or Evergreen, you know. There are a lot of schools that let you go in lots of directions at once.
You mentioned multimedia. I was curious, you didn't mention virtual reality. How do you think that will affect society?
Are you interested in virtual reality?
Very.
There's a new book out called American Substitute for Nature that you should read. It's a great book. The thesis of the book is that Americans never really have liked nature except something to improve on. And it kind of talks about, kind of Protestant Christian pilgrims. And they kind of sort of a leftover European agony and worship. And then it talks, the next point is Disneyland. And he says this kind of typifies the directions that we've taken, because now instead of being in a somber church, we're out in Anaheim. And instead of having these kind of tortured icons, we got Mickey Mouse. And that what we're into is fun. And then he projects this into virtual reality, which, like many people, he feels is attractive to people who can't deal with real reality. And what he says is that the direction that we're taking is to be able to artificially handle our environment and optimize it for our own pleasure. The interesting thing about the book is it's not judgmental. And you read it and you think that's awful, I guess. And it's confusing. You should read it. Virtual reality is coming. I don't know what it's going to do to us. Up there.
A couple of comments. First of all, I'm enjoying your talk immensely.
Thank you. That's 3 drinks I owe people, yeah.
A second to our high school friend down here. My son has just gone into college, and in fact, both of them I recommended that you start down a technical path, because if you do that, you have the freedom to move off into another path. If you start down a non-technical path, it is more difficult to move into the technical path.
Or at least it doesn't happen. I mean, the statistics bear him out, that there are very few non-technical students moving across, a very large number of technical people crossing off. And I don't know why that is. There's a wonderful woman named Elizabeth Cannon, who is president of Mount Holyoke, a well-known liberal arts school, still women. And I see her once in a while, and she always has the same request. She said, Jim, she says, you haven't answered my request. And her request is that she wants to know how to give Holyoke students what she calls the wonderful arrogance of physicists. Now, she doesn't want them to be physicists. It's just one of the strange things about a technical education, and this is good and bad, is when people take a technical education, they sort of figure with an evening in a book they can do anything. You know, they can write the great novel, they can do the great historical essay, which is one reason they're annoying to people. I tend to call it intellectual confidence rather than arrogance, but it is true that English majors don't think that they can do physics the way that physics majors think they can do English. So there also is a kind of it's a confidence. It's that, you know, if you can pass this dumb course, you can do anything. And I think it's a help. But that's good advice. Can I swing over here now?
I got a couple of things yet to
Yeah.
finish. One of them is you're talking about the problems with the pyramids. There was, I understand, a bent pyramid that was a result of a structural failure. It started out going at a fairly steep slope. And
too steep. And then it does this.
Right.
Yeah, it's your basic highway department road cut. You don't have to go to Egypt to see that.
The final thing, though, was a question. This is really why I came down here. Is, what are the strong directions or things that you think that we should be looking at and be concerned about in the future? Things that we should be maybe attacking a little bit harder?
Well, I think that we have to worry a lot about the quality of life in the society. And I can start with transportation. Any city is no fun to drive in at quitting time and starting time. I can sort of television, huh? You know, 600 channels, okay, but give me something on those 600 channels. And also, I think electronic communication has the potential to individualize us. In other words, it does make it possible to be apart and communicate and do things, but it kind of breaks up community in a sense. And some of you may have noticed that if you work someplace that's gone heavily to electronic communications, especially for a lot of people who work at home now, the social element of life's gone. So I think we have to start worrying about that kind of thing with technology. There's some things that are going to come on so strong and so scary that we better start worrying about them, and I can say recombinant anything having to do with DNA. Some of these things are philosophically unsettling them, Some of them are just amusing. I don't know if you follow it. You can alter the DNA of a cow so that the milk is highly insulin rich. And then you can then simply process the milk and make insulin. And that's happening now. So insulin factories now consist of these big dirty cows in these stalls, you know. Well, this is a whole new kind of a pharmacological approach. So we're going to be going more and more towards technological products that come through a biological stream. And that's something that, as I say, it's so controversial. It already is with genetically engineered plants and things like that, that we better get into it. And it's an interesting one because the majority of engineers have not done chemistry. There are more physics-based engineers than chemistries, and I think that has to turn around. And then the other one, of course, is medicine. Technology does wonders in medicine, but as you know, you who bravely tried to pass the law, it costs a bunch. So I think that the economics has to be factored in more. So, and I think there is more and more of a tendency to get engineering students to think about costs beyond the straight economics, real costs. I want to go over here now, not to cut you off. I'll see you later. Yes?
When I was an undergraduate at Stanford 25 years ago, a lot of the technological research done was paid for by the U.S. Defense Department because of the war. And I'm curious about how much research is still funded by the American Defense Department, and if there are committees amongst faculty now that look at the use of research done on a university campus in relationship to defense issues.
Class of '67, huh?
I'm a little younger than that.
That was an exciting time, wasn't it?
Oh, it was.
I came there in '66, straight out of aerospace.
So did I. I was there in '66.
Okay, straight out of aerospace with a crew cut was I. I shall never forget that. No, the amount of DoD funding is still high, but the worry is way down. You know, students don't remember those days. Students are more off into issues having to do with gender, ethnicity, equity, and so on right now than they are worried about war. And whatever steam was in there left when the Soviet Union came apart.
But what about professors?
Oh, professors made their vote in 1966 and have pretty much stayed there, or 1971. In other words, some research was moved off campus to SRI. That was the classified research. Some professors decided they didn't want to do DoD work, and they figured out, good professors do bring in money. They figured out other funding sources. There's also a lot of research that DoD will not back. We have a hugely increased amount of environmental work, for instance, that DoD doesn't back. There's a lot of industry-backed work on digital electronics. So there are a lot of new areas that just simply are not DoD fundable. DoD money continues to be more consistent with pure research than any other agencies. In other words, DoD still has the luxury, if you would, of being less specific about what they want than, say, NIH or NSF or something like that, which is one reason it's been attractive. But it's going away, too. Not because of our activism on our part, but because the DoD budget's getting whacked. But the university is much more boring than when you were there. Over here.
Yes, I'm delighted to hear someone speak that not only knows good words, but knows what they mean. There are a couple of things that distress me. The first is that a big part of the writing for popular consumption on technology and science is written by writers who are word artists, but by golly, they don't know what some of those words mean. I'm wondering what can be done about that, and I hope you can continue to do lots of writing to push some of those out of the way. The second thing is entirely a different sort of thing. I'm distressed by all the company executives who write the numbers on their own paychecks.
The second one, the company executives who write numbers on their own paycheck, I don't have much control over, but it's obviously, it's attracted national interest. And I think it's attracted the interest of the boards of directors. And a lot of that have come through efforts not only of this, who's the guy that used to do studies of executive paychecks and then turned into a crusader. And then others have come because of activism in the business magazines, who have been running endless articles correlating executive raises with company performance, typically on the automobile business and so on. Now, I missed a lot of your first question. Did you hear that, Terry? Could you repeat that first one?
Yes, I'm distressed by the fact that a big part of the writers for popular consumption are just word artists that don't know what the words mean.
Ah,
They
the
make
language.
some horrible goofs.
Well, we elder faculty do what we can. The comment had to do with the quality of the English language. We elder faculty do what we can. It's hard. It's hard for several reasons. One is, for some reason, the word processor has given people a license to be sloppier in their writing. And I think part of it traces back to email, which most people write very informally. I mean, email I get at work, typically there's no punctuation and no capitals, and it's kind of E.E. Cummings style. That's also starting to be more and more of what I get from students. And it's very frustrating because I just said, if the students all write on the word processor, it takes them a whole 12 minutes to correct their stuff, so I just send it back now.
Well, I don't think I made myself real clear.
What?
I think the quality of their writing is beautiful, but the words they use sometimes are not the right words. They don't understand what they're writing about.
Oh, they don't understand the concepts.
Right.
Well, I mean, I can't fix that either. You flatter me. But I can tell you one thing that a lot of people are trying. We have a thing called a Knight Fellowship program that brings professional journalists in for a year. And we find a tremendous interest on their part in taking courses in science and math and engineering to try to understand the concepts. And from that comes a lot of interaction and so on. I think that there's a real desire on the part of a lot of people in media to understand the concepts that they're writing down, but there's limited opportunities for them to do that. Because, like I say, there aren't that many accessible courses, and I think a lot of companies are suspicious of media people and don't want to spend the time to educate them and are not even sure they want them to understand exactly what's going on. So I think it goes right back to education.
I agree.
Up there.
Hi. As you have pointed out throughout your talk, the science has been recently, particularly for the last few years, has been a group activity. So you have heard that in Iowa, that a graduate student killed a professor, and I also heard that there are professors who curse their student, call the student little shit. So apparently there's a problem. It happens in group activity. So,
Are you referring
management the professor probably should know something about managing their students. Actually, all professors, all scientists can't work on the project just by themselves, right? And so, do you think that? What do you think of the idea of having professors go through management training?
No. Professors don't go through management training and generally work well with graduate students and not always. And some of them probably should be jailed or something. But there is no concerted overall training of professors on how to work with PhD candidates. And that's just a tradition in the educational system. But there's also a very great difference of opinion on what that relationship should be. For instance, professors in Europe interact very differently with their students than professors in the US, than professors in whatever. When I first came to Stanford, I had worked in a company, and it was on a first-name basis. And we have quite a few students from other countries. And I was just in the habit of saying, "Hi, I'm Jim." And I found out when I walked up to a graduate student from India and said, "Hi, I'm Jim," they got very uncomfortable, because they were used to using a title. And, there were other countries where if I walked up and was very informal, they would really try to take me for everything I was worth. So the problem there, of course, is we have European professors, and we have, professors from China and professors from all different places, and they have a cultural different attitude in how to work with students.
So wouldn't you think that a more management skills on the professor's side would actually make the team more productive?
Well, I know a person who is French, was educated in French, and taught in France, and he considers that the appropriate management style to use with graduate students is total dominance. Now, you know, all I can say to him is, hey, you know, I think French style really sucks, or something. but I can't really go into an argument because he has contempt for me. So
Thank you.
I think your point is a good one. You know, we're really nearing the end of this, and I hate to cut you off, but I think maybe what we should do is and I feel bad about these. Here's my proposal. I'll go through a few of these, and then anybody who wants to hang around a few minutes, I guess we've got, no? We'll just cut it. I'm going to owe some of you a drink. Let me just read some of this. I will give half facetious quick answers. Why do people fear technology, and what can you do to prevent it? I think fear is either valid or because of unfamiliarity. I think some people's fears of technology, as in nuclear annihilation, has validity. I think others is just because it's foreign and strange, and I think education is the cause. How can technology help get the benefits of technology to the masses at the lowest ends? I think there's where a pure capitalistic system may not work, because companies are interested in profitability, and there are a lot of things that people at the lowest ends need that are not the highest profit output. So I think there needs to be some kind of either subsidization or some other plan made to do that. I know exactly what you're thinking of. One of the real tragedies now, for instance, is that medical equipment is custom built and very expensive. How do you get wheelchairs for people on the low end if there's no VA subsidy? Could creativity become dangerous? Sure. It can give you nervous breakdowns. Could too much keep us from being careful? Yeah. But as a society, I think right now that isn't the problem. I think we got enough inhibitions and traditions built in that we're not going to get in trouble by being too creative. That's usually true of individuals too. Most of us are very safely conservative, and there's lots of bells and whistles that'll go off before we get in too much trouble. I get this question. I teach courses in creativity, and a lot of my colleagues come up, colleagues is what you call friends in universities, come up to me and they say, gee, aren't you worried that your students will get too creative? And I say, give me a break. Someday I'm going to have some effect on somebody, maybe. So it isn't that dangerous. And then one more, and the others are great. Why can't different levels of technology coexist, and why we slide down? We're proud of our technology. Part of the company's overall identity is in its technology. We love putting that guy on the moon, even though you can't eat the moon. You know, we're proud of our defense things, even though there's a lot of anti-war sentiment and so on. Most of my anti-war friends would kill for a ride in an F-15. So there's a tremendous and long-term pride in our technological ability. And I think that's one of the things maybe that keeps us from, you know, a lot of people talk about adequate technology, appropriate technology, and things like that. And I think that one of the reasons is that we're just a company that has won through, a country that's won through technology, and we love it, for better or for worse. With that, the clock says stop. This pile of questions is very flattering, as is your attendance. Thanks a lot. Huh?